We're going to talk some about how we can quantitatively and visually describe the different sizes of grains in a particular soil. And the first particular graph that we're going to talk about is something that's known as a ternary diagram. And ternary from I think it's probably related to 3 to triangle. So the idea here is that you have a triangle. And on this triangle, imagine that you'd taken a soil and you'd just gotten rid of all of the big stuff, so you were left with the sand and the silt and the clay. And you somehow sorted it so that you could weigh how much clay was in it, you could weigh how much silt and weigh how much sand, and you wanted a graphical depiction of those quantities. This is the way that they do it. So on this axis, these are actually plotting axes, even though it's a triangle. We're going to have the weight of clay as a percentage of the total sample mass. And so we'll go over here. And it's going to be increasing from the bottom. So from 0%, 20, 40, 60, 80, all the way up here, 100. Then over here, I'll put a little arrow to kind of denote that this is increasing this direction. Up here, we're going to have, on this axis, the silt percentage weight. And instead of going horizontally across, this one's going to go downward parallel to this far side here. So it's going to start also here at 0. This one here is going to be 20. $40, $60, and $80. And then down here, we're up to 100. So it's increasing this direction. And now finally, we've got one more to draw in here. And this is going to be the percent sand. And it will be increasing this way, so we're kind of going around the triangle. So here for the sand, we've got, it's going to be lines parallel to this axis, 0. This one here will be 20. This one here will be 40. One here, 60, and then finally 80, and then 100. Okay, oof, difficult thing to draw. So let's say that someone told you that they had a sample that was 20% clay, 20% silt, 80% sand. How would you actually plot this thing on here? So the clay axis, you know it's going to be 20% clay. It's going to be somewhere along this horizontal pink line. The silt, it's 20% silt, you know it's going to be somewhere along here. We've already found our intersection right here. 20% clay, 20% silt. Oops, these numbers don't add up to 100%. This should be 60. Right here, we've automatically gotten, because there's only there's not that many degrees of freedom here, it's automatically been determined that we're in the right spot here. So we plotted ourselves on here. Why do people use this? Well, in various soil classification schemes, they'll draw out regions here and say, this region up here corresponds to clay. This region here corresponds to loam. And it's just a way of quantitatively associating those qualitative terms with the actual grain size abundance. Okay, so that was the ternary diagram. There's one other way of depicting this, and let's say instead of just lumping into these big categories, let's say instead that you could measure the size of every single particle, and you knew its diameter in millimeters. And let's say that here you had 2, and anything bigger than this is gravel. So bigger than 2 millimeters. We'll go down to 0.05. This will be the sand region in here. We'll go down to 0.02. This will be silt. And then everything smaller than 0.02 millimeters we're going to call clay. Okay, so this is some kind of like logarithmic scale here. It's not a linear scale on the x-axis. The tricky thing about this, the way that we're going to draw this, we're going to draw these as distributions, as lines here. And I'm going to go from 0% to 100% here. And this y-axis is going to be something that you can think of as percent finer. And the way that this works is that, let's say we had a sample from a river bed that was almost all gravel. That particular sample, it's not going to have a lot of these small grain sizes, but it's going to have a ton of gravel. So it's going to be kind of a line here, and it's going to shoot up here to get to 100%. And the idea is that at any point on here, what this curve is telling you is that if you were to pick a point here, right here, it'd say 50% of this particular sample has a grain size that's this size or finer. In other words, only about 10% of the sample has a grain size that's finer than gravel. It's a predominantly gravel sample. And then this point here is saying 100% of the sample is this particle size or smaller. So let's draw another one on here. For example, maybe we've got something like a sandy sample. You're going to see the steepest part of this curve. This is another way of describing this is like a cumulative frequency or cumulative distribution curve. The steepest part is going to tell you where from 100% to 10% of the sample falls in this sand size fraction. So this is sand. I think I forgot to draw this, to note that this was a gravel. People really like loams in their gardens. One of the characteristics of a loam is that it actually has got a fairly straight line here. And this means that it's got a decent fraction of all of these different grain sizes. It's got maybe 30% that's clay, another 30% that's silt, and then something up here that's sand. So it's well distributed. So this is another way of describing the abundance of different grain sizes within a particular sample.